You're standing on a chunk of the sun, once pure fire, now cooled, carrying oceans and life across the void that's floating in a cosmic dance floor in the middle of nowhere. Stars exploding, galaxies colliding, black holes eating everything like cosmic vacuum cleaners. And yet, you're still here scrolling YouTube. Ever wondered how the heck this is even possible? Buckle up, because we're about to speedrun all of physics. And no, this isn't going to be boring textbook stuff. We're talking apples falling on heads, planets missing the sun, and quantum particles breaking every rule in the book. Look down. That thing holding you to this rock? That's gravity. Newton discovered it when an apple hit him. Probably not as epic as the movies show, but enough to make him go, wait, things pull on each other? Turns out, everything with mass attracts everything else. Yes, even you. You're technically pulling on the moon right now. Not much, but enough to make you feel less single. Talcott Newton wrote it down. Ted force is equal mass multiplied with acceleration. And that's not just math. That's why a basketball either swishes into the hoop or obliterates your neighbor's car window. Same force. Different result. Planets? They're basically falling forever. The sun's gravity is yanking them inward, but they're moving so fast sideways that they just miss. Over and over. That's why orbits exist. Imagine throwing a ball so fast it never lands. That's Earth around the Sunday. Simple, right? Well, not really. Pluto's orbit looks like a drunk spaghetti noodle. But hey, it works. Mass is how much stuff you are. Weight is how much a planet's gravity pulls on that stuff. On Earth, you might weigh 80 kilograms. On the moon, you'd weigh way less. Same body, less gravity. So you're not overweight, you're just stuck on the wrong rock. Energy is like money. It can't be created or destroyed, only transferred. Lift an apple. You've converted chemical energy, your breakfast, into gravitational potential energy. Apple is charged. Drop it. Boom, it turns into kinetic energy. Work equals force multiplied by distance. If you try to lift something but it doesn't budge, physics says you've done zero work. Your feelings don't matter here. And when you slam the brakes on a car, the kinetic energy doesn't vanish, it morphs into heat, warming the air molecules. Fun fact, temperature is just tiny particles wiggling faster. Lava lamp? Just happy molecules dancing. Entropy is the universe's way of saying, everything's falling apart. Ice cubes melt, rooms get messy, stars burn out. It's disorder spreading endlessly. That's why time only goes forward. You never see a broken phone spontaneously reassemble. Even your fridge, defying entropy to make ice, is lying. It dumps more heat into the room than it cools. Total entropy always wins. Always. Zap! You just turned on a light. Electrons, tiny negative charges, are rushing through wires. That flow is current. The push making the move is voltage. Things resisting the flow? Resistance. And just like gravity, charges pull and repel each other, opposites attract, same charges push away, like awkward X's at a wedding. Maxwell's equations, 4 big scary formulas, explain it all. Even cooler? Move a magnet, and boom, you make electricity from nothing. That's induction. The reason wireless chargers feel like sorcery. Shake a charge fast enough, and you launch waves, ripples of electric and magnetic fields zooming through space at light speed. Sometimes you see it as visible light, but most of the spectrum is invisible. Wi-Fi, X-rays, microwaves basically, magic radio spaghetti all around you. Zoom in on anything, your hand, your phone, your cat, and it's just atoms. Atoms have protons and neutrons, built from quarks, wrapped in a cloud of electrons. Change the number of protons, you get a new element. Change neutrons, you've got isotopes, some of which are so unstable they spit radiation that can cook you from the inside. Split an atom's nucleus, fission, or smash two together, fusion, and a tiny bit of mass disappears, turning into a colossal amount of energy. That's why nuclear bombs and stars are insanely powerful. A little mass goes missing, Einstein smiles, and you get an explosion brighter than your future. At tiny scales, particles don't behave, they throw physics out the window. Electrons don't orbit neatly, they exist as a fuzzy probability cloud, being everywhere at once until you look. That's superposition. Try to pin down both their position and speed? Nope. Heisenberg's uncertainty principle slaps you in the face. Even weirder, shoot one photon through 2 slits, and it goes through both. But watch it closely. And it chooses one. Observation changes reality. Particles are waves. Waves are particles, and your common sense doesn't apply. Welcome to quantum land, where Schrodinger's cat is alive and dead until you peek. Einstein rolled in like, Newton's great, But gravity isn't a force, it's bent spacetime. Mass warps the fabric of the universe, and objects just follow the curves. That's why astronauts float and planets orbit. If you fly near light speed, time literally slows down for you. Twins could age differently. GPS satellites have to account for this, or your maps would be wrong. Reality bends for light speed limit. From apples falling to stars exploding, from electrons dancing to space-time bending physics, is the rulebook running this cosmic video game. And if you're still watching, congratulations. You now know more physics than 99% of TikTok.